Let's discuss question number 21. Here we have the question. For a reaction, what's the reaction given? 2 chlorine atom that is in gaseous state is converted into a chlorine molecule that is also in gaseous state. See, 2 chlorine atom, beginning you have 2 chlorine atoms, 2 chlorine atoms, they are combining to form a single chlorine molecule. So let's study what happens to the entropy of the reaction. Student, left side you can see that 2 chlorine atoms are there, so they can move anywhere, so their degree of randomness is very greater, so delta S or the entropy change is positive. Then what about the RHS? In product side you can see only 1 chlorine molecule, degree of randomness, what happened? Decreases, right? So when 2 chlorine atoms combine to form a chlorine molecule, the entropy of the reaction becomes negative. Negative means 2 atoms to 1 molecule. Randomness decreases, entropy also decreases. Entropy decreases mean negative. So we can say during this reaction, the entropy of the reaction is less than 0, means negative. Then what happens to enthalpy of the reaction? What is happened to the enthalpy of the reaction, whether it is positive or negative? Student, here you can see 2 chlorine atoms are the 2 chlorine atoms and they are combining together and forming a chlorine molecule. So when 2 chlorine atoms trying to make a bond between them, what will happen? Bond energy will be released. During the bond formation, energy will be released. So it is a exothermic reaction. For an exothermic reaction, what is the enthalpy of the reaction? It will be negative value, right? For an exothermic reaction, enthalpy is negative. So we can say that here delta H is also less than 0. So which option corresponding to delta S less than 0, delta H less than 0? Yes, that is equal to option 2. So question number 21, option 2 is the answer. Now, let's go to the question number 22. Find out the solubility. Which chapter? Solubility, ionic product, solubility product, everything we studied, grade 11, the chapter equilibrium. Then, find out the solubility of NiOH twice. What is the species given here? Nickel hydroxide, NiOH twice in 0.1 molar NaOH. So, you have a system here which contain nickel hydroxide, NiOH twice and NaOH. Okay. Student, you know very well, NiOH twice on dissociation, NiOH twice on dissociation, you will get 2 ion. One is Ni2 plus and you have 2OH minus, right? Now, given that the ionic product, what we need to find out here? Solubility, we need to find out. What is given here? Ionic product means the solubility product already given. So what is the solubility product? The representation Ksp. Solubility product or ionic product is given here. The value 2 into 10 to the power minus 15. That is the value given. We have to find out solubility S. We have to find out solubility S. Okay, let's find out. Simple question. Here NiOH twice, dissociation we got Ni2 plus and 2OH minus. Let me take the solubility of nickel 2 plus is S. So here what will be that? 2 moles, right? So it will be 2S. So solubility of nickel 2 plus, 1 mole nickel 2 plus S. So 2 mole it will be 2S. Now, if it is S and 2S, see student, here NiOH twice is present in NaOH. What is that? NaOH. So NaOH on dissociation, you will get Na plus and OH minus, right? So in your compound, you have 2 type of ion. Nickel 2 plus, OH minus, Na plus, OH minus. Which is the common ion in the system? The common ion is hydroxide ion, OH minus. So this is called as common ion effect. See, NiOH twice, you know, it's almost a weak. It will not undergo complete dissociation in water. But NaOH, it is a strong base. It will undergo complete dissociation in water. So what will happen? the OH minus ion concentration changes, but nickel 2 plus no changes, it is S, right? So OH minus ion concentration changes. What is the change? Let's see here. So here I already told you nickel concentration is S, OH minus concentration is 2S. So what is the expression for solubility product? We can write it here. Solubility product is the product of nickel 2 plus and OH minus. Take the coefficient as the power, right? So nickel 2 plus and OH minus square. So it will be almost nickel 2 plus concentration. You already got it. What is that? S. So what is the OH minus square? That is 2S, right? 2 OH minus concentration, you have 2S. But there is a thing. Already we discussed that OH minus ion concentration is changed because NaOH is also there. It is a strong base. So let's see what happens to the OH minus ion concentration. Initially you have 2S. What is that 2S? That is from nickel hydroxide. Then you have, and from NaOH also you have some particular amount of OH minus. What is that? See, in the question they given, you have 0.1 molar NaOH. 0.1 molar NaOH. So what is the concentration of OH minus ion? 0.1. So from NaOH you have 0.1 molar mole per liter OH minus ion. So total OH minus ion in the mixture is 2S plus 0.1. But student, when you consider 2S and 0.1, we can neglect the 2S and it is equal to 0.1. Why it is so? I told you NiOH twice is a weak electrolyte. So it will not undergo complete dissociation. So it will not give that much amount of OH minus. But NaOH, it is a strong base. It will give you more amount of OH minus. So 0.1 we can consider. So we can neglect 2S. So overall it will be 0.1. Now let's calculate. We have the expression Ksp. What is Ksp value given in the question? 2 into 10 to the power minus 15 is equal to nickel 2 plus, what is the concentration? S, right? Into, what is the concentration of OH minus? What is the concentration of OH minus? That is converted to what? 0.1, right? So 0.1 the whole square. So we need to find out S. So S is equal to 2 into 10 to the power minus 15 divided by, what is 0.1 square? 0.1 is equal to 10 to the power minus 1. 10 to the power minus 1, the whole square become 10 to the power minus 2. So what we can say that? It's equal to 2 into 10 to the power minus 13. That is the value of solubility. Okay, so question number 22, the answer is 2 into 10 to the power minus 13 molar. Answer is 3. So we have to discuss here common ion effect also. That will change your OH minus ion concentration. Okay. Now let's go to the question number 23. What is the question? Simple question. On electrolysis of dilute sulfuric acid. We studied lot of electrolysis in our chapter electrochemistry grade 12. On electrolysis of dilute sulfuric acid using platinum electrode, the product obtained at anode will be, what is the product you are getting at anode? We studied for the electrolysis of dilute sulfuric acid, what is the reaction takes place at cathode and what is the reaction takes place at anode? We studied at cathode, what is the reaction? You know, the water, dilute medium. So water is the, water contain H plus ion. Sulfuric acid also contain H plus ion. This H plus ion will react with the 2 electron, or it will gain 2 electron, is converted to what? 2H plus gaining 2 electron and converted to what? H2, right? It is in gaseous form. H2 gas. Then what about anode? What is reaction takes place at anode? Anode, student, OH minus, right? 4OH minus is converted into 2 water molecule along with the oxygen gas. How? Oxidation, it's anode. Anode means what? Oxidation. Oxidation means what? Losing electron. How 4H minus converted to this one? By removing 4 electron. Here we see 4OH minus converted to 2H2O, O2 and 4O minus. So that at cathode, which gas is producing? Hydrogen gas is producing. At the anode, which gas is producing? Oxygen gas is producing. That is a question. At anode, which gas is producing? Which is that? Oxygen gas. Answer is 4. Question number 23, answer 4. Right. Let's go to question number 24. Very simple. What is the question? Which of the following is not correct? Listen student, not correct about carbon monoxide. In grade 12, in grade 11, we studied about P block chapter. But carbon family we studied in grade 11, right? Carbon family. So carbon monoxide. What is the first statement? Carboxyhemoglobin. You know what is carboxyhemoglobin? When oxygen combined with the hemoglobin, you will get oxyhemoglobin. When carbon monoxide combined with the hemoglobin, you will get carboxyhemoglobin. So the carboxyhemoglobin, that's already given. What is that? Is less stable than oxyhemoglobin. Is it correct or not? It is incorrect, student. This is your answer. Why it is so? That's specifically given in your textbook, that NCERT textbook. What is that? Hemoglobin when combined with oxygen, oxyhemoglobin, but carbon monoxide having 300 times, right? Carbon monoxide have 300 times more affinity towards hemoglobin than oxygen. Okay, so we can say that the carboxyhemoglobin is more stable than oxyhemoglobin. They given less stable. That's wrong. What is, let's check it the other option. Second option is given. It is produced due to incomplete combustion. Yes or no? Carbon monoxide is produced by the incomplete combustion of carbon compounds. Yes, that is a correct statement. What about third? It forms carboxyhemoglobin. Yes, absolutely. What about fourth one? It reduces oxygen carrying ability of blood. Right? That's also correct. So what is the answer for question number 24? That's equal to 1. Right? Simple. Now let's go to question number 25. The number of faradays. Student, what is mean by faradays? Which chapter? Electrochemistry, grade 12. What is mean by Faraday? 1 Faraday means the charge of 1 mole of electron. What is that? 1 Faraday means charge of 1 mole electron. See, the number of Faradays required to produce 20 gram of calcium. 20 gram calcium from molten calcium chloride. See, what is calcium chloride? CaCl2. Calcium chloride on dissociation, you will get the ion Ca2 plus and 2Cl minus. Here we no need Cl minus because they are asking the question related with the 20 gram calcium. Okay, we have 1 mole Ca2 plus. See, 1 mole calcium. Okay, Ca2 plus. Here what is happening? Ca2 plus, you have 1 mole Ca2 plus. Ca2 plus can gain 2 electron and it can convert it into Ca. Correct or not? 1 Ca2 plus ion which can gain 2 electron and convert it to 1 calcium. Okay, so we can say that 1 mole calcium, right? For getting 1 mole calcium, see how much electron is required? 2 electron. So 2 electron correspond to what? 2 farad, right? What is 1 farad? Charge of 1 mole electron, that is 1 farad. So 2 electrons are there for the conversion of Ca2 plus into Ca. So how much farad? For 1 mole calcium, 2 farad is required. So the question, 1 mole calcium, student, 1 mole calcium, what is the mass? 1 mole of calcium, 40 gram. What is the question here? For 20 gram, how much? For 40 gram calcium, 2 farad. So how much about 20 gram calcium? 20 gram calcium, how much required? Only 1 farad. Right. So your answer can be write it as question number 25 is option 3, 1. So once again, 1 farad means charge of 1 mole electron. Here 2 moles electrons are there, therefore 2 farad. So for 20 gram, only 1 farad. Now let's go to question number 26. Here we have elimination reaction of 2 bromopentane. Elimination reaction we are studying from our 11th grade onwards. So elimination reaction of 2 bromopentane. So let me write. What is 2-bromopentane? CH3, CHBr, CH2, CH2, CH3. This is your compound 2-bromopentane, which is undergoing elimination reaction. You know that's in presence of alcoholic KOH. It forms pent-2-ene. Normally, during dehydrohalogenation or beta elimination reaction, two products you will get it. What is this? Bromine and bromine directly attached, the functional group directly attached to carbon is said to be alpha carbon. So this is the alpha carbon. Nearest carbon is said to be beta. So you have two beta carbon, right? So you can say, what is meant by beta elimination reaction, student? Beta elimination means halogen from alpha carbon, one hydrogen from beta carbon is eliminating and you will get a double bond between them, between alpha and beta. So there are two beta carbon atom we can take. Either you can eliminate this hydrogen and this bromine, so you have to develop a double bond here. So you will get the compound CH3, CH double bond, CH single bond, CH2, CH3, 2-pentene. Either you can remove hydrogen from this beta carbon and bromine from here and you will get a double bond. So you will get CH2 double bond, CH single bond, CH2, CH2, CH3. What is the first product? Pent-1-ene. What is the second product? Pent-2-ene. So what is the process here happen? Beta elimination, right? Beta elimination takes place. So first reaction is beta elimination. After that, you are getting two products. Among that, one of them is major, one of them is minor. Which is the major product? Pent-2-ene is the major product and Pent-1-ene is the minor product. Why it is major? We studied according to Seitz's rule. According to Seitz's rule, more substituted alkenes are more stable. See here, alkene, left, right side, more substituted by alkyl group. But here, less substituted. So, more substituted alkene is more stable. So, according to Seitz's rule, this is the Pent-2-ene is the major product. So, we applied beta elimination and Seitz's rule. What is happening here actually during the reaction? See student, let me take once again the compound CH3CHBr. Let me write one of the hydrogen like this and CH2CH3. What is happening here? The hydrogen from the beta carbon is eliminated with which one? Br. So this hydrogen and Br is eliminating, they are creating a double bond. So during beta elimination reaction, one hydrogen and one halogen is removing from the system. Therefore, it is called it as dehydrohalogenation. So, what other reaction is proceeding here? Beta elimination, Seitz's rule and dehydrohalogenation. Can we call it as dehydration reaction in any one of the steps? No. Dehydration means elimination of water. Water is not eliminating here. So, we can say first step is beta elimination, Seitz's rule, dehydrohalogenation. A, B, C is the correct order. Yes, answer is third one. So, question number 26, that is answer third one. Now, let's go to question number 27. What is the change in oxidation number? Redox reaction chapter 11th grade we studied how to find the oxidation state of carbon, right? Of carbon. Here you can see here methane reacting with the chlorine, you are getting carbon tetrachloride and HCl. So here only we have to consider carbon compound because carbon oxidation state they are asking. So what is the carbon? CH4 converted into CCl4, right? Here we can see that CH4 converted into CCl4. Okay, so here what is the change in oxidation state of carbon? See student, let's calculate the oxidation state of carbon. Let me take it as X. What is the charge of one hydrogen? Plus 1. Because carbon and hydrogen when you are considering, carbon is the electronegative one, right? So we can take X. So hydrogen is an electropositive element. So having plus 4 charge, right? 1 hydrogen plus 1. So 4 hydrogen plus 4 is equal to 0. So X is equal to what? Minus 4. So in CH4, carbon is in minus 4 oxidation state. What about in CCl4? We don't know about carbon. Let me take it as X. 1 chlorine, see chlorine is an electronegative element, so it will get a negative charge. 1 chlorine minus 1, so 4 chlorine minus 4, so minus 4 equal to 0. Here X is equal to what? Plus 4. So during this reaction, minus 4 converted into plus 4 oxidation state. What is the answer? Answer is A. So question number 27, answer is 1. Right. Let's go to question number 28. In question 28, which of the following alkane cannot be made in good yield by Wurte's reaction? We are studying from 11th grade, Wurte's reaction, hydrocarbon chapter. What is Wurte's reaction? Two alkyl halides reacting with sodium in dry ethereal solution, it will give higher alkanes. Is called it as Wurte's reaction. The getting product which contain the higher alkane which contain even number of carbon, or we can say that there is a symmetric alkanes are producing. Wurte's reaction is limited to the preparation of symmetrical alkanes. Let's see which of them are symmetrical. The first compound is given heptane. What is heptane? 1, 2, 3, 4, 5, 6, 7 carbon containing alkane. What is meant by normal butane? 1, 2, 3, 4 carbon. What about normal hexane? 1, 2, 3, 4, 5, 6 carbon. What is the last compound? 2,3-dimethyl butane. Butane 2,3-dimethyl. This is the compound, right? Let's see which of them are symmetric and unsymmetric. See, heptane, it's an odd number, right? Heptane, 7 carbon. So that is not a symmetric arrangement. We told you that Wurte's reaction is using for preparation of even number of carbon containing alkanes. So here you can see 4 carbon, there is a symmetric. Here is a 6 carbon, there is a symmetric. Here you can see there is also a symmetric. So these kind of alkanes can be prepared by Wurte's reaction because they are having even number of carbon and having symmetric. But odd number, especially unsymmetrical alkanes, cannot be prepared by Wurte's reaction. So the answer is which one? Normal heptane is the answer. So question number 28, answer is again 1. Now question number 29. So simple question, you are a NEET student, directly you can answer. Sucrose on hydrolysis gives, from the chapter grade 12 biomolecule, we studied there are three type of disaccharides we completed. Sucrose, maltose, lactose. Sucrose on dissociation or hydrolysis, it will give you alpha D glucose and beta D fructose. So what is the answer? Alpha D glucose and beta D fructose. So the answer is 1. Now here we have the question number 30. Identify the incorrect statement. Identify the incorrect statement. What is the first statement given? Interstitial compounds are those that are formed when small atoms like hydrogen, carbon or nitrogen are trapped inside the crystal lattice of metal. Yes or no? We studied in hydrogen chapter. There are 3 type of hydrides: ionic hydride, covalent hydride, interstitial hydride or metallic hydride. Interstitial hydride mean in the crystal lattice, the trap that hydrogen, such kind of small elements, hydrogen, carbon, nitrogen, they will trap inside the system, right? That is called interstitial hydride. Yes, that is a correct statement. What about second statement? The oxidation state of chromium in CrO4 2- and Cr2O7 2- are not the same. Let's check it. What is the compound? CrO4 2-. Let's calculate what is the oxidation state of chromium here. See all of you, chromium, let me take it as X. 1 oxygen charge is -2. So 4 oxygen -8. -8 is equal to, what is the overall charge? -2. So X is equal to what, student? +6. So in this case, chromium is in +6 oxidation state. Let's calculate about the second species. What is given? Cr2O7 2-. Let's calculate what is the oxidation state here. Chromium, let me take X. So there are 2 chromium, therefore 2X plus 1 oxygen -2. So 4 oxygen -14. Sorry, 7 oxygen -14. Overall equal to -2. So what we can say? 2X is equal to plus 12, x is equal to plus 6. See all of you, in both case oxidation states are the same. But what they said, oxidation state in these two compounds are not the same. Yes, that is the incorrect statement. So question number 30, answer is 2. Let me check it with the third one. Cr2 plus with a D4 configuration is a stronger reducing agent than D6. Any doubt? Let's check it, student. D4, right? You have a D4 configuration. Student, D4 configuration means they will try to get it. They will try to get one more electron to make it D5, half-filled destabilization. So they are trying to gaining electron, right? They are trying to gain electron. What is meant by gaining electron is called it as reduction, right? Gain of electron is called it as what? Reduction. Reduction means what? Reduction means what? The substance undergo reduction mean they can act as a oxidizing agent, but they given it is a reducing agent. That is also wrong statement. Then what about fourth? The transition metal D block element, their compounds are known for their, D block elements having catalytic nature. Nickel, platinum, palladium used as a catalyst. Why? They having property to show variable oxidation state. Yes, multiple oxidation state. That is also correct. So the answer for question number 30 is clear that second. Now come to question number 31. HCl was passed through a solution of calcium chloride and magnesium chloride and NaCl. Which of the following compound crystallize? Very simple. Magnesium chloride and calcium chloride form which one? Amorphous compound, right? Magnesium chloride and calcium chloride form amorphous compound. Sodium chloride, solid state, lot of time we study sodium chloride is crystalline in nature. So crystalline one, only the option is given fourth one. So question number 31, simple answer, fourth. Here we have question number 32. Identify the correct statement. Identify the correct statement from the following. Right. Option A. Carbon dioxide gas. Read the sentence very carefully. Carbon dioxide gas is used as a refrigerant. No, it's a wrong statement. What is wrong here? Carbon dioxide solid carbon dioxide is called it as dry ice. That is used as a refrigerant for keeping ice cream and frozen food. Okay, option B. The structure of C60 in our grade 11 we studied Buckminster fullerene C60 carbon containing compound. In C60, they are saying 12 6 carbon ring. No, it contains 12 pentagon, 5 carbon, 12 pentagon. They given 12 6 carbon. That's wrong statement. What about C? ZSM5. What is ZSM5? Grade 11 P block we studied. Zeolite, zircony, mobile. ZSM5 is used in petrochemical industries in order to convert alcohol into gasoline. Yes, that is a correct statement. What about option D? Carbon monoxide is a colorless and odorless gas. Yes, it's absolutely correct statement, right? Grade 11 P block. So C and D, which are correct statement. So C and D only, second one is the answer. So question number 32, option second. Now, here we have question number 33. An increase in the concentration of reactant. We are increasing the concentration of reactant of a reaction leads to the change in whether threshold energy, whether collision frequency or activation energy or the heat of reaction. We were studied, right, in the chapter chemical kinetics, we studied that collision theory. According to collision theory, is the number of reacting species increases. Number of reactant increases or the reacting particle number increases, collision frequency increases, right? Number of particles increases in reactants, the collisions increases, collision frequency also increases. What is mean by collision frequency? We studied the factor Z. What is collision frequency? Number of collisions per second per unit volume of the reaction mixture is said to be collision frequency. So we can say that as the number of reactants increases, collision frequency also increases. Answer for question number 33, is 2. Yes. Question number 34. The calculated, many times we discussed this one, the calculated spin-only magnetic moment. How to calculate magnetic moment, student? Nu is equal to root of n into n plus 2 Bohr magneton, right? Bohr magneton. Root of n into n plus 2. What is n here? Number of unpaired electron. Number of unpaired electron. What is the species given here? The species given here, chromium 2 plus. See student, chromium atomic number, you know, 24. The last two shells will be 4s2 3d4. 4s2 3d4. Due to stabilization, it becomes 4s1 and 3d5, right? So chromium 2 plus means how many electron? 22 electrons only, right? From where it will remove the first 2 electron? From 4s, because that is the outermost shell. So from 4s, if it is removing 2 electron, it becomes 4s0 3d4. See student, 4s0 3d4. In 3d, you have 4 electrons. In 3d, you have 4 electrons, right? So how many unpaired electrons are there? Very clear that, right? 1, 2, 3, 4. There are 4 unpaired electrons. So let's substitute here n value. We can substitute that root of 4 into 4 plus 2. 4 plus 2, 6. 6 into 4 equal to 24. 24 equal to 24. Student, here root 24. Root 25 is equal to 5. So root 24 is nearby 5, right? That's equal to what? 4.90 Bohr magneton. So for the magnetic moment of Cr2 plus is 4.9 Bohr magneton. Answer is fourth one. Now, let's go to question number 35. Again, a simple pattern of question. Yes. Match the following and identify the correct option. Let's see. First, compound A is given carbon monoxide and hydrogen. You studied in the S block element chapter, P block, everywhere you studied about what is mean by carbon monoxide and hydrogen mixture is called it as what? Synthesis gas or syn gas, right? So carbon monoxide, option A, which is goes to third one. Option A, third one. 3 options are there. Let's check it the second one. Temporary hardness of water from the chapter hydrogen grade 11. We studied 2 types of hardness of water are there, temporary and permanent. Temporary hardness is because of calcium and magnesium present as their bicarbonate salt, right? What is permanent? Calcium, magnesium present as their chlorides or sulfate, right? So temporary hardness is because of magnesium, calcium present as their bicarbonate. Let's goes to B1. So A3, B1. Only one answer is given, third one. Let's check it. C also. B2H6. You know student, boron family elements, when they form hydrides, they are electron deficient. We studied in grade 11 the hydrogen chapter. We classified hydride into 3: ionic, covalent and interstitial. Covalent again we classified into 3: electron deficient, electron precise, electron rich. Where electron deficient means hydrogen combining with the 13th group element, boron family, right? So boron compound, boron hydrides are electron deficient hydrides. Yes, second one, which is that second one. H2O2. You know what is the structure of H2O2? H2O2 having a like structure, open book like a structure, right? Open book like structure. It is non-planar. Non-planar. Yes, D option goes to fourth one. Answer is third one. Clear? Right. Let's go to question number 36. The mixture which shows positive deviation from Raoul's law. You know what is Raoul's law? We studied in the chapter solution, grade 12. Raoul's law, we know those solution which obeying Raoul's law is said to be ideal solution. If it not obeying is said to be non-ideal solution. Non-ideal solution we again classified into 2. Hope you remember that. Which of them? Positive deviation. Positive deviation and negative deviation. Positive and negative deviation. In positive deviation, you studied lot of example. Positive deviation, what is the quantity, student? The AB interaction. What is AB? Solvent-solute interaction is weaker than solvent-solvent and solute-solute interaction. So what about negative deviation? Solvent-solute interaction is greater than solvent-solvent and solute-solute interaction. See, acetone and chloroform. Acetone and chloroform we studied in the deviation. Which one? Negative deviation, right? It's correspond to negative deviation. Negative deviation. What about chloroethane and bromoethane? See, student, what is the condition to form ideal solution? The combining compound should have almost a similar molecular mass. Chloroethane, bromoethane, a comparatively having almost a similar molecular mass. So they can form ideal solution. They are forming mostly ideal solution. Then ethanol and acetone. See, ethanol and acetone, when you are mixing, their interaction will be weaker than in their individual component. Ethanol and acetone. So this is belongs to which one? Positive deviation. Okay. C correspond to positive deviation. What about benzene and toluene? Benzene and toluene almost having similar molecular mass. So we can consider that also can form which one? Ideal solution. So what is the answer? The mixture which will show positive deviation. The answer is which one? The mixture ethanol and acetone. Now, question number 37. Lot of time we discuss the same type of question. That is from your chapter alcohols, phenols and ether. The part from ether. Anisole on cleavage with hydrogen iodide. Student, what is mean by anisole? You know, anisole is benzene with OCH3. Methoxybenzene is called it as anisole, right? Anisole, when it is treated with the hydrogen iodide. You know, hydrogen iodide contain H plus ion and I minus ion. The question, which bond that you are going to break? Which carbon-oxygen bond that you are going to break? Either you can break this CO bond, this one, or you can break this CO bond. But when an ether undergoing reaction with a hydrogen iodide, the carbon-oxygen bond in ether will break in such a manner the most stable carbonium ion or carbocation forming, right? If you are splitting this bond, you will get carbon and oxygen when you are considering which is the most electronegative element, oxygen. So it will prefer negative, it will prefer positive. See student, if you are carrying out this reaction or this cleavage, what is the product you are getting? You will get a phenoxide ion, right? What is this? Phenoxide ion, and you will get a methyl carbocation. See, this is phenoxide ion. It is highly stable due to resonance, right? It is highly stable due to resonance. It is highly stable. So, ether can undergo cleavage in presence of hydrogen iodide in such a manner that most stable carbonium ion or carbocations are forming. So, this is the best way. If you are break it here, least stable forming, right? So, we have phenoxide ion with a negative charge and CH3 plus. To this negative, what will attack student? H plus will attack, right? So what is the compound? Phenol. To the CH3 plus, what will attack? I minus can attack. So what is the product? CH3I. Where is your product? Phenol and methyl iodide. Yes, answer is third one. Question number 37, chapter alcohol, phenol and ether. From the pot, ether. Answer is third. Hope you get the idea. Let's go to question number 38. Urea react with water to form a compound A, which will decompose to form B. Let's proceed one by one. What do you have? Urea. What is mean by urea? You have urea is a diamide, right? NH2CONH2. This is the compound urea. So urea react with the water. Student, urea when it is reacting with the water, it will produce NH2CO. NH2CO. Then you will get OH here. From water, you will get OH. From water, you will get OH. So one H plus is left here. That H plus will combine with the NH2. What you will get? Ammonia gas. Right? Ammonia gas. And you can see here, let me take, this is your compound A. And this compound A, which will decompose, which on heating, it will undergo decomposition and forming the product B. What is the product B? Children, NH2 and this H. Let me take NH2NH, which is on decomposition. NH2H, what you will get? Ammonia NH3. What is left here? Carbon dioxide. Carbon dioxide. Okay. So, which is getting compound B. Okay, B. The compound B is forming. And when this is passed through, so ammonia is the compound B. Let me treat when it is passed through Cu2 plus. What is that? Passed through Cu2 plus. So, what you will get it? Ammonia, when react with the copper, you will get a ammonium copper complex, right? Coordination compound. What is that? CuNH3 4 time. Copper 2 plus will combine with the 4 neutral ligand ammonia, amine. You will get CuNH3 4 2 plus having a deep blue color. Deep blue color. The compound C is forming. So, this is the compound C. Question, what is the formula of C from the following? Yes, which is that? Option 4th one. Okay, so question number 38, answer is 4. Yes, let's go to question number 39. Simple question. Freezing point. Which chapter? Solution, grade 12. The freezing point depression constant. Student, Kf value already given to you. How much? 5.12. What is the unit of Kf? Kelvin, kilogram, mole inverse. Okay, fine. The freezing point depression for the solution of molality. Molality also given. How much? 0.078 molar. Almost you can take 0.08. Containing a non-electrolyte solute. They already specified non-electrolyte. Non-electrolyte means what, student? Like benzene. They will not undergo dissociation. Right? Non-electrolyte solute in benzene. What we need to find out? The freezing point depression. So, depression in freezing point. We need to find out. What is depression in freezing point? Delta TF. We need to find out. We have a simple equation. Delta TF is equal to Van Hoff factor I into Kf, constant into molality. I, it's equal to 1. Why it is so? Because it is a non-electrolyte. It will not undergo dissociation. So, we can write 1 into, what is Kf value given here? 5.12 into, what is molality? 0.078. While calculating, almost you will get the answer. Option 1, 0.40. So, question number 39, answer is 1. No need of further calculation, very simple, direct question. Within second, you can calculate the answer. Let's discuss question number 40. Which of the following oxo acid of sulfur has oxygen-oxygen linkage? Very simple question. See student, hydrogen peroxide, you know, H2O2 having HOOH. There is a oxygen-oxygen linkage. That is called peroxide linkage. See, peroxide linkage is where is present. The name itself is giving the answer. Peroxo, right? Simple answer, option 1. How is that? We have studied about the structure of all these compounds in grade 12 P block chapter, right? In the oxygen family, you have H2SO3. That is called it as sulfurous acid. What is the structure? Sulfur having one lone pair. 2 hydrogens are connected by OH and one more oxygen is there, that is by a double bond oxygen. This is the structure of sulfurous, right? There is no OO linkage, right? Then what about sulfuric acid? H2SO4. What is that? Sulfur, double bond O, OH, OH. This is called it as H2SO4. There is also not having any OO linkage. Then what about another one? H2S2O7. Pyrosulfuric acid or oleum. What is the structure? Sulfur, double bond O, sulfur, double bond O, 2 hydrogen. Exists as one OH, one more oxygen. Like this. This is called pyrosulfuric acid. Then what about another one? Last one. H2S2O8. Peroxodisulfuric acid. Here one more H2S2O7, H2S2O8, one oxygen extra. Oh, you have to put it here between. So you will get S double bond O, double bond O, S double bond O, double bond O. Here one OH, here one OH, two oxygen linkage. Here you can see peroxide linkage is only present in which one? Peroxodisulfuric acid. Answer is 1. So question number 40. Option 1. Question number 41. Identify the correct statement from the following. What is the first statement? Vapor phase refining is carried out for nickel by Van Arkel method. It's a wrong statement, right? Question correct statement. Why it is wrong? We studied in the metallurgy chapter. Vapor phase refining are classified into two. Van Arkel method and Mons process. Van Arkel method is used for the purification of which of the metal? Zirconium, thorium, titanium. Mons process is used for nickel. Here they are giving vapor phase for which one? Van Arkel method for nickel. That's wrong. Now, what about second one? Pig iron. You know, pig iron is the most impure form of iron, right? During the blast furnace, molten iron, that is pig iron. Pig iron contain, 4% carbon. Pig iron can be molded into varieties of shape. Yes, it can be molded into any other desired shape. Yes, that is correct one. What about third? Wrought iron. Wrought iron is the pure form, right? Let's contain less amount of carbon. Wrought iron is impure iron. No, it's a pure iron. That is a wrong statement. What about fourth one? Blister copper. Blister copper, pure form, around 99.9% pure. Blister copper has blistered. Why it is blistered? Because of the appearance due to evolution of carbon dioxide. No, it's given in your NCERT textbook because of the evolution of sulfur dioxide. Okay, so the correct statement is which one? Second one. Fine. Now let's go to question number 42. Which of the following is a natural polymer? In polymer chapter grade 12 we studied how can you classify the polymers according to their source. Natural, semi-synthetic, synthetic. See, polybutadiene acrylonitrile. You studied about pan everything. Cis-1,4-polyisoprene. Polybutadiene styrene. Which is the natural polymer? Option third one. Cis-1,4-polyisoprene. Yes or no? What is mean by isoprene, student? What is isoprene? What is mean by isoprene? 1,3, right? 2-methyl, 1,3-diene, butadiene. 2-methyl, 1,3-butadiene is called it as isoprene. Isoprene, which will undergo, this is natural rubber, right? Cis-1,4-polyisoprene is what, student? Natural rubber. Natural rubber monomer is which one? Isoprene, right? So this will undergo polymerization. What you will get here? CH2, this double bond will transfer here. CH3, double bond, CH, single bond, CH2. This is called it as natural rubber. This is called it as isoprene. So natural rubber, the monomer, right? Isoprene. So which is the following is a natural polymer? Answer is third one. Now question number 43. So simple question, no need of any calculation, direct substitution. An element has body-centered cubic BCC structure. Which chapter? Grade 12 solid state, right? In BCC, you studied in BCC geometry or structure. What we need to calculate here? Edge length already given. What is edge length? A, right, is equal to 288 picometer. And the atomic radius, we need to find out radius. We have for a BCC system, what is the relation between radius and edge length? What is the relation? Radius is equal to root 3a divided by 4. Right, root 3a divided by 4. Already given, what is a? Root 3 into, what is a? 288 divided by 4. What is answer? Root 3 by 4 into 288. Third one. No need of further calculation, direct substitution. Question number 43, answer is 3. Now let's discuss question number 44. An alkene on ozonolysis gives methanol as one of the product. Its structure is, what is the structure of alkene? See, we studied what is meant by ozonolysis from your grade 11 organic chapter, right? Hydrocarbons. What is meant by ozonolysis? When an alkene treated with ozone, first it will form a ring compound, that is called it as ozonide. Then ozonide, which when treated with a zinc and water, it will undergo lysis, right, breaking, and it will get either aldehyde or ketone, depends on the alkene. So here we need methanol, right? We need methanol as one of the product. See, during ozonolysis process, no need to write all the mechanism, ozonide formation, everything. We can directly calculate it. How is that? Here is the double bond. Just split the double bond and you make one oxygen left side, one oxygen right side, over. What is present here? Cyclohexane, then CH2CHO. This is not methanol. What is present on the right side? What is present on the right side? What is mean by methanol? HCHO, right? Formaldehyde. This is your methanol. Here we are getting CH2O. CH2O. What is CH2O? CH2O is nothing but HCHO, right? Formaldehyde or methanol. So your answer is which one? 1. What about 3, second, third and fourth? In second one, where it will break, here it will break. You can substitute one oxygen. Will you get methanol? No. It's a big compound, right? What about here? You can split it here, make a oxygen here, right, left and right. Here you can see cyclohexane carbaldehyde, CH3CHO, ethanol, not methanol. Then what about here? Here you can split it, put oxygen. There is also not getting any methanol. So only one answer, that is which one? First one. So during the ozonolysis of an alkene, you will get methanol only from the first one. Okay. Let's go to the last question in chemistry, question number 45. Which of the following set of molecule will have zero dipole moment? Chapter chemical bonding, we studied in 11th grade, 4th chapter, right? Zero dipole moment. We're so simple. See, first option, nitrogen trifluoride. What is nitrogen trifluoride? NF3. You know what is NF3 having a dipole moment? You studied in 11th grade, NH3, NF3 comparison. NF3, what is the geometry, student? It is having a trigonal pyramidal geometry, right? Trigonal pyramidal geometry. It is having a dipole moment. You know very well, right? It is having a dipole moment. So we cannot consider not option number 1. Question is which is having zero dipole moment. So not option 1. Let's go to option 2. Boron trifluoride. What is boron trifluoride? BF3, right? What is the structure of BF3? Trigonal planar. So BF3, trigonal planar. And what is another one? Beryllium difluoride. What is beryllium difluoride? BeF2. What is the geometry? Linear geometry, right? Then, what about another one? Carbon dioxide. What is carbon dioxide? CO2 with COO, carbon dioxide. What about the last one? 1,4-dichlorobenzene. What is that? Benzene, first and fourth position, 2-chlorine. 1,4-dichlorobenzene. See all of you here carefully. Boron, fluorine, when you are considering, fluorine is most electronegative. So see student, all their dipole moments are cancelling each other. So their dipole moment is equal to 0. What about BeF2? Be and fluorine when you are considering, fluorine is most electronegative. So they are also cancelling each other. So dipole moment is equal to 0. What about carbon dioxide? Carbon, oxygen. Oxygen is most electronegative. They are also cancelling each other. Dipole moment again 0. What about the last one? Chlorine is most electronegative. That is also cancelling each other. Again dipole moment 0. So your second option, all of their dipole moments are 0. In option 3, ammonia, you see already we discussed beryllium difluoride and 1,4-dichlorobenzene. Their dipole moment is 0. But you know water and ammonia having dipole moment. So that is not an answer. Fourth option, boron trifluoride, we discussed, having zero dipole moment. Hydrogen fluoride, what is hydrogen fluoride? HF, right? Fluorine is most electronegative, so this is the direction. So they are having polarity or dipole moment. So what we can say that is hydrogen fluoride is dipole moment is present. So that is also not your answer. So question number 45, which of them having set of molecule having zero dipole moment? Your answer is which one? Second one. Chapter chemical bonding. So we completed all the NEET 2020 45 chemistry questions. See, most of the questions are so easy. So let's see again with lot of interesting question in the next class. Thank you all. All the best.
Brilliant Qatar is the passport to your success.